Hello, let's continue with another section, 4.5 Properties of Logarithms. Our objectives are 1. The basic property of logarithms, the product rule, quotient rule, and power rule. And the purpose of doing this is this might be a helpful tool when solving equations. So that will be our next couple of sections. Basic properties of logarithms. We have already introduced logarithms as the inverses of exponentials, learned how to evaluate logarithms, and establish how to convert logarithms to their exponential form using the definition. So we know that log base b of x equals to y is the exact same thing as saying b to the y power equals x. So these are used interchangeably. Now I highly recommend have this handy, make a post-it, just so that you can easily go from one to the other if necessary. We now need to investigate the properties of logarithms. We will start with 4 basic properties of logarithms. Property 1. Log base b of 1 equals 0. This can be interpreted as any logarithm of 1 is 0. This is because the exponential form is b to the 0 power is 1. So they're saying it doesn't matter what that base value may be. If I ever have the log of 1, my default answer needs to be 0. And this is the y. Because any number to the 0 power will give us 1. All right, property 2. Log base b of b equals 1. This is true because the exponential form of the property is b to the first power equals b. Two of the most common uses of this property will occur when working with the common and natural logarithms. And it will be advantageous to remember that. So this is saying if I'm taking the log or the ln of a number, my answer is 1 if the base and the value are the same. So here in our first little example, I have log of 10 equals 1, and this is because log base 10, if it's not written. We assume it's base 10. And the other one is ln of v is 1, and that's because we know that ln of v is log base e. So log base e of e, you see how we have the same base and the same value that we're trying to evaluate? So our answer must be 1. For the next 2 basic properties of logarithms, we need to recall that f of x equals b to the x power and g of x equals log base b of x are inverses of each other. And for any 2 inverses, we know that if we do composition of inverses, our answer should be x. So that f composed of g of x, our answer should be x like we have here, and vice versa. G of f of x should give us x. So because of this brings us to property 3. Log base b of b to the x gives us x. And property 4, b to the log base b of x equals x. Though it's not proper to say, my trick to think about it is if I have the same base and base value, we know that gives us 1. And with the future values, we can bring this forward. So our answer would be x. Same thing here. These are inverses, thus cancel each other out. And with future rules that we'll learn, we can bring this forward so that we just have x. Example 1. Simplify the following properties using the 4 basic properties above. So log of 1. We said by the first property, if I ever have to take the log and my value that I'm working with is 1, by default, my answer needs to be 0. So that we have log of 1 equals 0. Here we said that if we have the same base and value, that would give us 1. So log base 5 of 5 gives us 1. Here, we assume it's a base e because ln is log base e. So that e and e make 1. So we're left with just our exponent, which is 4. Next, same idea, we have the same base and value, so they undo each other and we're just left with our exponent, which is x. Same thing for the next one. 10 and log base 10 are inverses, so we're just left with our exponent, which is x plus 1. All right, 3 substantial properties of logarithms. The 3 most important properties of logarithms are called the product, quotient, and power rules. Since logarithm functions are the inverses of exponential functions, these properties will mirror the product, quotient, and power rules of exponents. So first we have the product rule. And what this says is if I have the log of the same base, and if I'm adding them, if that's the case, I can rewrite this using only one log. And the value that I'm working with can be multiplied, like we have here. So let's see an example. Log example 2. Use a product rule to write the following expression as a single logarithm. So see how we have the same log with the same base, and they're being added. That's important. If they're being added, I can write it as one log and multiply them. So I have log of 3 times 5, and I can multiply that, it gives us 15. So I have simplified it to be log of 15. And that's the same thing as writing log 3 plus log 5. All right, B. I have the same base, ln, and they're being added. So let's write it with one log. So that I have ln of x times x minus 1. Now, if we ever have a situation like this, we can multiply, distribute. So we have x times x gives us x squared, and x minus 1 gives us minus x. Example 3. Use a product rule to write log base 3 as x squared times square root of x plus 2 as a sum of 2 logarithms. So this is the other way around. Now we want to expand using as many logs as possible. So even though it's not written, we know these two values are being multiplied. All right, so I can write x squared with one log, and I can write square root of x plus 2 with one log. So we now have log base 3 of x squared plus log base 3 of the square root of x plus 2. And that's how we can use our product rule to expand our expression. Next, we have quotient rule. Log base b of x minus log base b of y equals log base b of x minus y. So what this is saying is if I have the same log base, and this time, if they're being subtracted, I can write it using only one log, and I'm going to divide. I'm going to divide the first one on top, and the second one goes on the bottom. So this will be divided by x over y. Now, it's very important that we note that because we have an equal sign, I can go from writing it as multiple logs to a single log, or taking it from a single log and expanding to multiple logs. It can be used either way. Example 4. Use a quotient rule to write the following expression as single logarithms. Right, so I want to write it using only one log or one ln. Here I have two logs with the same base and they're being subtracted. All right, our quotient rule says I can write it with a one log and use division. So I have log base 2, and then I have my first number, which is x, on top, and then I'm going to write my second number on the bottom. So x over 3. Log base 2 of x over 3. Same thing for our next problem, B. I have log, and I'm subtracting. So I can write it using one log and division. So I have log of x over x plus 2. Example 5. Use the product and quotient rules to write log base 4 of x y over z as a sum and difference of 3 logarithms. All right, so first thing that might catch our eye is that division. And we know that division can be rewritten as subtraction using multiple logs. So I'm going to subtract the top minus the bottom. So I have log base 4 of my numerator, x times y, and then I have minus log base 4 of z. Now something we need to emphasize is that even though it's not written, we know that x and y are being multiplied. And whenever we have multiplication, I can expand it using addition. So x and y will give us log base 4 of x plus log base 4 of y minus log base 4 of z. So we have finished our problem and we have written it as multiple logs. Power rule. Log base b of xt, the same thing as t times log base b of x. So what this is saying is we can go ahead and take an exponent and bring it to the front, like we have here. This way I can undo an exponent and use it as a coefficient. Let's take a look at example 6. Apply the power rule to rewrite the following as an equivalent expression. All right, so we see this exponent here. What can we do with that? Well, if we don't want it as an exponent, I can always bring it to the front and multiply it to our log value. So that we have x plus 1 times log of 2. Same thing here. We see this square root. Any square root can be written as a 1/2 exponent. If we have a cube root, it would be a 1/3 exponent. If I have something like a square root of a number that's being raised to a power, then my square root will be my denominator and my exponent would be a 3. Just to recall how that looks. So I can write this as ln of 5, and instead of writing a square root, I can write an exponent 1/2, like we have here. So if I don't want that as an exponent, I can always bring it forward and multiply it. So that I have 1/2 times ln of 5. And for c, I can always go the other way around. If I have a number multiplied in the front, I can always write it as an exponent. So this is log base 4 of x squared. The remaining portion of this section will be to separate examples that will help commit the properties of logarithms to memory. So I know I've suggested to write our rule for log to exponential form in this post-it. This is also a post-it piece of information. So make sure you write your product rule in a post-it. That's important. Make sure you write your quotient rule as a post-it. That's important. And also write your power rule and a post-it. Having those two handy, easily to see right next to you will make it easy. All right, so we read that. Let's go ahead and do example 7. Use the properties of logarithms to write each logarithm as a sum or difference. All right, so let's take a look at A. I want to write it with a sum or difference, so as addition and subtraction. All right, I see we're dividing, so I know that's subtraction. So I can subtract using 2 ln's, the top minus the bottom. So I have ln squared minus ln of xz. And again, even though it's not written, when I have two variables together, we know they're being multiplied. So I can write this using a sum. So I have ln of my first number plus ln of my second number. In this case, it's ln of x plus ln of z. But the part we need to be careful about is that we're subtracting the entire value of ln. So I need to bring down that concept. All right, from there we have to distribute that negative, so I can drop those brackets. So I'm left with minus ln of x minus ln of z. And lastly, we can take our exponent and bring it forward. So we have 2 ln of y. And this would be our answer. B. Log base b of x times the square root of y over z to the fourth power. So to begin, we see everything's being held together by this cube, so let's get rid of it. Let's move it to the front and multiply it so that we have 3 log b of x times square root of y over z to the fourth power. All right, I see division, which I know I can interpret as subtraction, so I can subtract the top and subtract that, put a minus sign, and subtract the bottom. However, all of this is being tied together with that 3. So we're going to have to leave that 3 on the outside and use brackets. So I have log base b of x times the square root of y minus log base b of z to the fourth power. All right, I can go ahead and have multiplication, so I can use my sum rule, my product rule, and I can write log base b of x plus log base b of square root of y. All right, now I want to work with these exponents. I know that square root is the same thing as writing a 1/2 exponent, so let's do that here. All right, now let's make those exponents coefficients. So let's move them forward. We have another exponent here. So that we have 3 times log base b of x plus 1/2 times log b of y minus 4 times log b of z. And last piece, we want to distribute that 3. So multiply that 3 to every term in your expression. So I have 3 times log base b of x. I can multiply my fractions, 3 over 1 times 1 over 2. So that gives us 3 over 2 times log base b of y, and 3 times 4 gives us 12, so I have minus 12 log base b of z. A lot of work. My biggest advice is please rewrite your problem for each step you're working with. It might be a lot of writing, but I often see that if you try to save writing and do multiple steps at once, that's when I see mistakes happen, so be careful. Example 8. Use the properties of logarithms to write each expression as a single logarithm. All right, with this one, I'll go ahead and do A. I think you can do B on your own. So A, I need to see what we have to do. So let's work from left to right, or whichever way you like to work. But pick 2. And here I see a minus. When I see a minus, I know I can write it with 1 log as division. But I need to get rid of that 2 in the front. What can I do to get rid of that 2 so that I only have log? Because I only need to have log and log. And this 2 is giving us a trouble. So let's take that 2 and write it as an exponent. So I have log base 5 of x squared minus log base 5 of y plus log base 5 of z to the fourth power. Now I can go ahead and divide. So I'm going to write both of those with only 1 log. And I have my first over my second. So x squared divided by y. Now I'm left with log base 5 of x squared over y plus log base 5 of z to the fourth power. Addition, we know we can write it with a single log and multiply. So we write it with a log and multiply both of them together. Now, if you're ever unsure, just write it down and then you can work it out. Now I know I can multiply fractions across. So this gives us x squared times y times z to the fourth power divided by y. We have now written it as a single log. All right, I'll let you try B on your own. Well, let's just do it. It's pretty quick. All right, I want to write it as a single log. I see subtraction, so I know to treat it as division. But I first have to get log and log. So I need to get rid of those exponents that we have going on. You can do that by, well, making them exponents. So we have log of x squared plus 1 with the exponent of 1/2 minus log of z cubed. All right, now I can write it. Now that I have log only, I can write it as a single log and divide. I divide top, division sign, and then our second. So I have x plus 1 to the 1/2 power divided by c cubed. Lastly, we don't like these rational exponents, so let's write it as an alternative, a square root. So I have the square root of x plus 1 divided by z cubed to give us log of the square root of x plus 1 divided by c cubed. All right, so this is the section. I think it would be very helpful to take the time and write post-its for the power rule, the quotient rule, and the product rule. And if these rules, these first 4 properties might seem something that you might forget, make sure you write them down too and just have them handy. They'll serve helpful in future sections. All right, that's it for 4.5. Thank you.